Guys, start of another week. We will start with the homework. Okay, so we did prisms on Friday. Excuse me. So find the volume and surface area of the following prisms, and I just asked you to do part B. So to find the volume, we need to get the area of the face, so the consistent face that's going to pass through the entire shape. And we multiply that then by the depth, which is that bit there. Okay, so to get the volume, as I said, we do area of face multiplied by the depth of the shape. There we go. So the face is a triangle, and the formula for the triangle is half AH. Why is that so thick? Sorry, we'll try that again. Half AH, where A is the base and H is the perpendicular height. Okay, so the base of the triangle is 24, so that's grand. Now the perpendicular height, we have the same problem we had in the example I did on Friday. That's the perpendicular height. So we're going to need to figure it out. So I'm just going to draw it again. This is 15, this is going to be 12, and this we don't know, and my right angle is there. So it's c squared equals a squared plus b squared. The hypotenuse is 15. So it's 15 squared equals 12 squared plus x squared or b squared, whatever. Actually, probably could have called it h, given it stands for the height. So that is 225 equals 144 plus x squared. We minus the 144 to cancel it, and we minus the 144 for balance. So we have x squared is 81, and then we square root to get x is 9. So the height, the perpendicular height, is 9. So 24 by 9 divided by 2 is 108 centimeters squared for the face. And then I still need to multiply that by the depth. So I multiply my 108 by 43. So that is 4644 centimeters cubed for the volume of that shape. And then for the surface area, so we have the triangular face, which we've already figured out the area of. It was what, 108, and we have 2 of them. I am writing this, I'll show you now. Okay, so we had the triangular face, which we had figured out over here to be 108, and then there's a triangular face at the front and a triangular face at the back. Okay, we then have the slanted sides, okay, which when we were doing this on Friday we established were rectangles. And so I'm looking this bit here. Yeah, so it's going to be 43 in length and then 15 in width. So it's length by width, which is 43 by 15. And that is 645 centimeters squared. And again, there's two of them. So that's 1290 centimeters squared. And then I know the one we did on Friday didn't have a bottom, but this one does. So you can kind of, if I take the colors back off maybe, you can see it there. That's the base there. So it's 20, it's still a rectangle and it's 24 by 43. So then we have the base, which is a rectangle, which is length by width, 24 by 43, isn't that what I said? Yeah, 24 by 43. Is 1032 centimeters squared. Okay, so then we have all of the sides, I think. So we have the two triangular faces. We have the two slanted sides. And we have the base. So add them all up. And we get a total surface area of 2538 centimeters squared. Yep. Okay, and then the second one, a cuboid has side lengths in the ratio 2:3:7. Find the dimensions if its volume is 2688. Okay, there's probably a few ways to do this. The one that's coming to mind for me is that basically to get the volume of a cuboid, it's length by width by height. Okay, we know the volume is 2688. And basically, if they're in the same ratio, it means that this 2, 3, and 7 are multiples of a given number. So let's say one side is like, let's say the 2, I'm going to rub this out now, but let's say this 2 here, okay, represents a 20 centimeter side. Yeah, that means the 3 has to be 30 centimeters, because if 2 is 20, then 3 would be 30, and then 7 would be 70. Okay, so they're all multiples of some number. So if I just let x be the number, and it becomes like 2x by 3x by 7x, I think this will work. So then I have 2688 equals 2 by 3 by 7 is 42, and then x by x by x is x cubed. I'm going to divide by the 42. Hope this works. And I get 64 equals x cubed. I'm pretty sure we've done this before. If you get rid of a square with a square root, you get rid of a cube with a cubed root. And there's a button on your calculator for cubed root. So I take the cubed root of the other side. So it's shift square root to get a cubed root, and then type in 64. So that is 4 centimeters. So essentially, if it's 2 is to 3 is to 7, the first side is 2 4s. Yeah, so that's the length. The width is 3 4s. And the height then is 7 fours. Okay, that's what I meant. They're all multiples of some number. We just had to find the number, so why not make it x? So I don't know if anybody comes up with a different way of doing that, but that's my way. Okay. Right, so we'll just move down here. Monday the 15th. Okay, so today, here, I want to look at cylinders, spheres, and hemispheres. So cylinders we did already. Well, we did the volume. Okay, the volume is ordinary level. So the volume of a cylinder, you can see it there. Okay, finally. The volume of a cylinder is pi r squared h. Yeah, it's there. I'm going to get rid of that, but the volume of a cylinder is pi r squared h. Now, the surface area of a cylinder is not on the ordinary level course, okay? So I'm going to start with cylinder, and volume is the first one. So volume we did already, it's pi r squared h. Now, the surface area, okay? If you think about a cylinder, there's two there in the page, okay? We have this bit of the cylinder, okay? That's the curved part of the cylinder. And then we have this bit, and then obviously we have another one of them here. And that's the flat surface area. Yeah? So to get the surface area of a cylinder, it is a combination of the curved surface area and the flat surface area. Okay? What they give you in the formula and tables book is just the curved surface area. Okay? Because technically they do give you the flat surface area in the formula and tables book, because the flat part of a cylinder is just a circle. Well, actually it's two circles. Okay? So when you look up the formula for surface area of a cylinder, it doesn't give you surface area, it actually gives you CSA, which is curved surface area. Okay? And the curved surface area of a cylinder, right? Now, listen to me. The curved surface area of a cylinder is actually just a rectangle, okay? The curved surface area of a cylinder is actually just a rectangle. Now, I'm going to show you the picture here, but if you don't believe me, the next time you run out of toilet paper, take the inside of the toilet paper and cut it. Roll it open and tell me what shape you're looking at. Okay, it's a rectangle. Okay, so if I bring you back over here, see they've done it. So they've taken the curved part and they've rolled it out flat. Okay, this top line here was wrapped around there, okay? So the top line, or the length of the rectangle, is actually the circumference of the circle. Yeah, so the circumference of the circle is the length of the rectangle, and then the width of the rectangle is just the height of the cylinder. Okay, now you don't actually need to know any of this because it's all in the formula and tables book, but I think it's nice to understand, okay? Because essentially you take something that's wrapped up into a circle and flatten it. This flattened out part up here was wrapped around here. So it's the same length as the circumference of the circle, okay, or the circumference at the top of the cylinder. And then you can definitely see that this bit here, which is now the width of the rectangle, is also the height of the cylinder. Okay, so that's where the formula comes from. So if I go back over, so the curved surface area, which like I said is essentially a rectangle is just length by width, but the length of this is the circumference and the width is the height. So the formula is 2 pi or h, and that's what's in the table book. Okay? And then what we have here is the total surface area. So that's like what I was saying here. Okay? The bit that you're given in the formula and tables book is only the curved part. If you want to get the complete surface area, you're going to have to add on 2 circles. Okay? And we know that circles are pi r squared. Just going to add on 2 of them. Okay, and that's what they've done over here. So they've taken the curved surface area and this bit here is the 2 circles. Yeah? Okay, so just be careful of that whole curved surface area versus total surface area. Next one then is a sphere. So the formula for the volume of a sphere is 4 over 3 pi r cubed. Can you see it there? And that is in the formula and tables book. And then the surface area. Now there's no discrepancy here between curved surface area and flat surface area because there is no flat part of a sphere. It's just all curved. So the surface area of a sphere is just 4 pi r squared. And then the hemisphere is just half a sphere. Now it is worth noting that these are not in the formula and tables book. Okay, but it's quite easy, okay? If you want to get, sorry. Hang on. What should I do? No, it's cubed. Did I say squared? Sorry, it's cubed. So then when you want to get the volume of a hemisphere, we back up to speed. So the volume of a hemisphere is obviously half a sphere. So all you do is half this. So instead of 4/3, you have 2/3 pi r cubed. Okay? And same thing with the, so you don't need the formula is what I'm trying to say. Okay, so if you have the surface area of a sphere, now as we said, there's no discrepancy with surface area of a sphere because there is no curved and flat part, it's just all curved. So that's 4 pi r squared. Now, a hemisphere, okay, the surface area of a hemisphere Okay, so same deal. There you go. You just have to half it. So it's 2 pi r squared. Okay, but when you cut a circle, or a sphere, sorry, in half, if you look at the picture over here, you create more surface, okay? You reveal this flat part. So now you do have the same discrepancy that we had with the cylinder. So that 2 pi r squared is only the curved part. It's only this part down here. Yeah? So that's obviously the surface area of a sphere. When you half that, you're only halving the curved part. So if you want to get the total surface area of a hemisphere, sorry, it will have to be the curved part, so TSA, total surface area, so to get the total surface area of a hemisphere, it will have to be the curved part plus the flat part. Now we know the curved part is 2 pi r squared because that's up above. And what's the flat part? It's just a circle. So it's pi r squared. Okay, so that's all the formulas, or the formulae. Okay, so one of them, the volume of a cylinder, that's the only one that was ordinary level. Everything else is new. Okay, make sure you understand this discrepancy between curved surface area and total surface area. The formula and tables book will only ever give you the curved surface area. Okay, so if you want total surface areas, you're going to have to include the flat bits yourself. Okay, and volume of a sphere, they are in the formula and tables book. Volume of a hemisphere is not, okay, but you simply half the numbers. Okay, but just remember when you're doing the surface area of a hemisphere that a sphere doesn't have flat parts, but a hemisphere does. So you'll have to include that. We'll do this one. The rest are just subbing into a formula, which I think you can do at this stage. So this is a bit more interesting. Okay, so a test tube consists of a cylinder joined to a hemisphere. The total length of the test tube is 13.5 centimeters. Its diameter is 7 centimeters. Calculate the height of the cylindrical parts of the tube. Okay, so the 13.5 goes all the way from the top of the cylinder to the bottom of the hemisphere. So we need to figure out what's the height of the hemisphere, because if we can figure that out, then we can subtract it off the 13.5. Okay, so if we take, this is a two-dimensional view, right, of our circle. Obviously it's a hemisphere, so we're only dealing with the lower part of it here. Yeah, we were told in the question, and there's a picture, that the diameter, this one here, is 7. If the diameter is 7, that means that the radius is 3.5. But remember, a radius doesn't have to go from left to right. It can also go like that. So that's what that is. It's 3.5. So that means the height of the tube is 10 centimeters because the hemisphere is 3.5. Find the total volume of the test tube in terms of pi. Okay, so we won't be subbing anything in for pi. Okay, so the volume of the test tube is going to be a hemisphere plus a cylinder. Okay, so if I was doing this in my exam, I'd go to my formula and tables book. I'd go to volume and surface area. So the first one is a hemisphere. We know not to expect a hemisphere, but there's the sphere. Okay, we have A for area, so it's not that because we're doing volume. So it's V for volume. So I'm going to take that formula. I'm going to write it down on my page. Yeah, so that's the volume that's the volume of a sphere. We're dealing with a hemisphere, so we're going to want to half this. So it's going to be 2/3 pi r cubed. Yeah. Then we go back in, and this time we want a cylinder. So there's my cylinder, and again I have A for area. That's not what I want. I want V for volume. So there is my cylinder formula. And I don't need to change that. That's just pi r squared h. Yeah? Okay, so start on the left. So 2/3 is 2/3. Pi, we said, we highlighted in terms of pi, so we'll just leave it. And then the radius of the hemisphere is 3.5. And we're going to cube it. Then plus, we leave pi as pi. And like the hemisphere sits perfectly at the bottom of the cylinder, which means whatever the radius of the hemisphere is, that's the same as the radius of the cylinder. So this is also going to be 3.5. And then the height of the cylinder we worked out in part A, that's 10. Okay, so 3.5 cubed times 2/3. I don't know why I'm doing it in the wrong order, times pi. So I'm getting 343 over 12 pi. Did I do that right? Yep. And then the other one is pi times 3.5 squared times 10, which I think is 245 over 2 pi. And then we add them together. Suppose leave it as a fraction. 1813 over 12 pi centimeters cubed is the volume of the test tube. Oh, why those numbers are so awkward. Sorry, I'm just going to try this, make sure I didn't do anything stupid. Plus pi 1813 over 12 pi. Yep. So that's it. And they asked for it in terms of pi, so I have to leave the pi. You can figure out what 1813 over 12 is as a decimal if you want, but there's no point. The fraction is more accurate, so leave it as a fraction. Okay, so that's the idea. So I've gone through all the formulas. They're all available in the formula and tables book, which you have on the OneNote page, so you know there's no excuse. It's all under, why did that got changed? It's all under volume and surface area, so we're in 3-dimensional shapes now. You'll find them all there. So yeah, your homework. I saw some really nice ones. Yeah. Okay, so we're going to go with number 7. In the right part. Yeah, okay. It's just not syncing for some reason. Okay, so we're going to go with number 7. Here, so Monday's homework. Okay, and then I saw another one No, this one. Oh, what should I do? Number 12 there. That was definitely a junior cert question, I think. I remember it being a nice one. So there are your 2 questions for homework. All right. So they are due for Wednesday. All right, lads. Thanks. Enjoy your day.